How often do you think about your heart health? Are you aware of the risks of cardiovascular disease? Well, let's dive into the heart of the matter. Cardiovascular diseases, encompassing coronary heart disease and stroke, claim the top spot as the leading cause of death in the United States. Particularly at risk are Blacks and Hispanics in underserved communities. It's a sobering reality, isn't it? But there's good news. Cardiovascular disease is largely preventable. Stay tuned to learn how you can keep your heart beating strong. Heart Smarts, a health program, is here to empower you to live a heart-healthy lifestyle. This program is not just about information, but about transformation. It offers a comprehensive approach to help you understand and achieve heart health. Heart Smarts is committed to reducing the incidence of cardiovascular disease, the leading cause of death in the United States. The program focuses on underserved communities where the risk of heart disease and stroke is greatest. Through education and empowerment, Heart Smarts aims to turn the tide on these statistics. It's a call to action, a call to change, a call to live healthier, longer lives. Heart Smarts is about arming you with the knowledge and tools you need to make heart-smart choices every day. It's about the power of prevention and the promise of a healthier future. Remember, Heart Smarts is not just a program, it's a life-changing journey. It's about taking control of your health, one heartbeat at a time. But don't just take our word for it. Listen to these stories from people who have benefited from Heart Smarts. Imagine being told you're at risk for heart disease, a leading cause of death in the United States. Now picture having the knowledge and tools to combat that risk head-on. For people like Maria, a single mother from an underserved community, Heart Smarts was a beacon of hope. The program informed decisions about her heart health, ultimately reducing her risk of cardiovascular diseases. And then there's John, a middle-aged man who was once a prisoner of his poor lifestyle choices. For him, Heart Smarts was not just a program, but a lifesaver. It opened his eyes to the risks he was taking and gave him the push he needed to commit to a healthier lifestyle. These are not just testimonials, they are life-changing stories. Stories of empowerment, resilience, and triumph over heart disease. These are real stories from real people who have seen the impact of Heart Smarts in their lives. Are you ready to be the next success story? Your heart health is in your hands, and with Heart Smarts, you have the power to make a difference. It's time to take that first step towards a healthier lifestyle, a step that could redefine your future. Heart Smarts is not just an ally, it's a beacon, guiding you to make informed decisions for your heart health. So why wait? The path to a healthier heart is just a click away. You'll find the link to Heart Smarts right down in the description below. Start your journey towards a healthier heart today with Heart Smarts.
Have you ever pondered what the universe is truly made of? What are its most basic constituents? Sit back and imagine, if you will, a cosmos woven out of the tiniest threads of existence. Now, what if I tell you that these threads aren't physical threads, but rather minuscule particles, invisible to the naked eye? Welcome to the extraordinary realm of particle physics, where we explore the universe's building blocks, the smallest particles that make up everything we see and don't see. In the grand tapestry of the universe, there exist particles so tiny, yet they form the very backbone of our existence. These particles, my friends, are known as quarks, leptons, and bosons. Each of these particles has a unique story to tell, a distinct role to play in the cosmic drama that unfolds around us every second of every day. Quarks, for instance, are like the tiny titans of the particle world. They're resilient, enigmatic, and form the heart of matter as we know it. Then we have the leptons, the lone wanderers of the particle universe, preferring solitude over the company of others. And lastly, we have the bosons, the force carriers, the negotiators, and the peacekeepers, ensuring that everything in the universe interacts as it should. But we're just scratching the surface here. The universe, in its infinite wisdom, is far more complex and intricate than we can possibly fathom. It's a cosmic puzzle, and these particles are the pieces we have in our hands. The rest of the puzzle, the bigger picture, is what we're trying to understand, to decode. So, buckle up, my fellow explorers, as we embark on this exciting journey into the heart of the universe. Together, we'll delve deep into the world of quarks, leptons, and bosons, and try to understand the fundamental forces of nature that govern our very existence. Stay tuned as we unravel the mysteries of these fundamental particles. Imagine the tiniest particles, so small that we can't see them, but they make up everything we can see. welcome to the world of quarks. Diving deep into the heart of matter, we find a bustling world of infinitesimal particles. These tiny titans are known as quarks, the smallest particles that we currently know of. They are the fundamental building blocks of protons and neutrons, which form the nucleus of atoms, the very foundation of our tangible universe. Quarks are not solo performers, though. They always come in pairs or trios, bound together by the strong nuclear force, one of the four fundamental forces of the universe. This force is so mighty that it binds quarks together, making them inseparable under normal conditions. But the family of quarks is not a small one. There are 6 types or flavors of quarks, each with its own unique properties. There's the up and down quarks, the most common and lightest members of the family, found in the protons and neutrons of every atom around us. Then, there are the charm and strange quarks, slightly heavier and less common, but no less important. And finally, we have the top and bottom quarks, the heaviest and rarest of them all, existing only in high-energy environments like those created in particle accelerators. Each quark has a corresponding antiquark, a particle with the same mass but opposite electric charge. This duality, this balance, is a fundamental principle in the world of quantum physics. So why do quarks matter? Because they are the foundation of matter itself. They are integral to our understanding of the universe and its workings. Without quarks, there would be no atoms, no molecules, no stars, no planets, and certainly no life as we know it. Quarks may be minuscule, but their impact is cosmic. They are the unseen architects, the silent builders, the invisible sculptors of the universe. With every heartbeat, every breath, every blink of an eye, quarks are there, building, binding, creating. Quarks may be small, but they bear the weight of our entire universe. While quarks prefer companionship, leptons are the universe's lone wanderers. These subatomic particles are like the introverts of the particle world, preferring to keep to themselves rather than mingle with others. Leptons are fundamental particles, which means that they cannot be broken down into smaller units. They are the elementary particles that are not subject to strong interactions. In other words, they don't play well with the strong nuclear force, one of the 4 fundamental forces of nature that binds protons and neutrons together in an atom's nucleus. There are 6 different types of leptons, each with a corresponding antiparticle, making a total of 12 leptons in the standard model of particle physics. They differ in their charge, mass, and the way they interact with other particles. The electron is perhaps the most well-known among the leptons. It's the lightest of the bunch and carries a negative electric charge. Electrons are the particles that orbit the nucleus in an atom and are responsible for electricity, magnetism, and chemical reactions. Then there are the muon and the tau, heavier cousins of the electron. Like the electron, they carry a negative charge, but they are much more massive and unstable, decaying quickly into other particles. Accompanying each of these charged leptons is a corresponding neutrino, the electron neutrino, muon neutrino, and tau neutrino. Neutrinos are elusive, nearly massless particles that rarely interact with other matter. They zip through the universe almost undetected, making them incredibly difficult to study. Despite their solitary nature, leptons are integral to our understanding of the universe. They're involved in a variety of phenomena, from the glow of neon lights to the destructive power of nuclear weapons. They're also key players in the study of high-energy physics, helping scientists uncover the fundamental laws that govern our universe. So, while they may be lone wanderers, leptons are far from insignificant. They're a testament to the fact that sometimes it's the solitary figures that hold the keys to understanding the complex tapestry of the universe. Leptons, though solitary, play a vital role in the universe's grand design. From the strong nuclear forces holding atomic nuclei together to the gravitational pull keeping us grounded, bosons are the unsung heroes. As we delve into the realm of particle physics, we encounter bosons, the particles that carry forces. Unlike quarks and leptons, which make up matter, bosons are responsible for acting out the fundamental forces of the universe. They are the couriers, the emissaries, the messengers that allow particles to interact with one another. Consider gravity, the force that keeps our feet on the ground, and the planets in their orbits. The hypothetical graviton, a boson yet to be detected, is thought to be the carrier of this force. Though elusive, the graviton forms an essential part of our understanding of the universe. Then there's the electromagnetic force, the glue that binds electrons to nuclei, enabling the creation of atoms and molecules. The photon, a type of boson you're probably familiar with, carries this force. It's the reason you can see, as light is made up of billions and billions of photons. Next, we have the strong nuclear force, the most potent of all, keeping the protons and neutrons inside atomic nuclei from tearing each other apart. The gluons, aptly named, are the bosons that carry this force. They are the peacekeepers in the subatomic world, ensuring stability and order. Lastly, the weak nuclear force, responsible for radioactive decay and nuclear fission, is carried by the W and Z bosons. These bosons, although having a short range, play a crucial role in the processes that power the sun and other stars. These four fundamental forces, through the actions of their associated bosons, shape the universe as we know it. They govern everything from the smallest particles to the largest galaxies, from the most fleeting moments to the age of the universe itself. Bosons are the glue that holds the universe together. They are a testament to the intricate and beautiful complexity of the cosmos. Without them, the universe as we know it would cease to exist. So here's to the bosons, the unsung heroes of the quantum world. Now that we know the players, let's explore the rule book of the universe, the Standard Model. The Standard Model is our best effort yet to understand the fundamental forces and particles that make up everything around us. This theory is like a cosmic jigsaw puzzle, where each particle fits in a specific place and plays a unique role. Let's break it down. The Standard Model includes three of the four fundamental forces: electromagnetism, the strong nuclear force, and the weak nuclear force. These forces are carried by bosons and act upon our quarks and leptons. The fourth force, gravity, is still the elusive piece of this puzzle. But how do we study these minute particles and forces? Enter particle accelerators. These machines are like superpowered microscopes, allowing us to peer into the very fabric of the universe. They work by propelling particles at high speeds, nearly the speed of light, and then smashing them together. The resulting energy releases new particles, which we can study to understand the universe on its most fundamental level. Particle accelerators have helped us confirm the existence of many particles predicted by the Standard Model, like the Higgs boson, often called the God particle. By studying these particles, we can test and refine our theories, inching us closer to a complete understanding of the universe's intricate design. Particle accelerators are our key to unlocking the secrets of the universe. We've journeyed from quarks to leptons, bosons, the Standard Model, and particle accelerators. We've delved into the tiny titans, the lone wanderers, and the force carriers that constitute the very fabric of our universe. The importance of understanding these fundamental particles and forces cannot be overstated, as they are the keys to unlocking the secrets of our reality. As we continue to explore, we become more connected to the universe and its intricate